So let's take a look at a very simple example of using multiple threads within an application. First of all, I created a console application in Visual Basic.net called Threading02 Console. And the very first thing that I did in the module1.vb, which is the default module in a console application, is that I created a public class at the very bottom of it, public class threading example. It has one public method called counter, and basically I just loop through 200 times this little console.writeLine statement, and in that I want to print out the current thread's ID, so they'll actually print out a number, and that will represent the current thread that's being used. It'll also print out the number of the 1 to 200, that for next loop. So now that I've created this class, what I want to do is call the counter method from a new thread that I'll create. So the first thing I do is I create an instance of the threading example class as called example. And then I create a new thread which I'm calling counter thread. So dim counter thread is new thread, and I pass in the address of example.counter. So this is the instance of threading example and the method counter. Now what goes on behind the scenes implicitly is that a thread start object is created, and it's passed this address in memory of the example.counter. So the thread start is a delegate. So if you ever wondered why you'd use delegates, this is one good reason why. In multi-thread applications you have to use a delegate. So the counter method is going to support the thread start delegate. Don't worry if I made it sound more complicated than it really is. Just have to kind of follow the example of what I've done here. Then further on down you can see the console.writeLine starting, and we want to print out the current thread that the submain is starting on. So the idea here is that we'll have a default or a main thread, and that is what is going to spawn off an additional thread called counter thread, and that very next line of code we call the dot start, and it will have a different thread ID. And let's loop down. This last line of code is just to allow us to see the results in Visual Studio.net before the console goes away. So let's do this. Let's save what we have here and run our application. 200 times to get to the very bottom. Now I want you to notice something. I'll go to the very top of our results and notice that the thread that it was started on was 1264. Then we spawned off a new thread which had the ID of 2036, and that was the thread upon which all of the numbers were printed out to the console window. So let's go ahead and stop this. And let's do something fun here. I want to create 2 additional threads and see what happens. So I'm going to just copy and paste this twice and call these 2 different things, like thread 2 and thread 3. Okay? And then here we'll copy this twice and we'll put in thread 2 and thread 3. So let's go ahead and run this now. What do you think will happen? Now the interesting thing won't be that we get 600 numbers, but the sequence in which these happen. If you remember from the little flash introduction that we did to threading in .NET, each thread would get so long to operate before the interrupt would kick in, and then that thread would have to defer to a different thread where the execution would continue. So we see a quick example of this in what our results right here. Unfortunately, because the console window only keeps so many results at a time, notice that it starts at 105 in my case. Your results are definitely going to be different depending on the speed of your machine and how many other applications are currently running. But as we scroll through thread 580 in my case, notice then that it stops in the middle and picks up thread 3832 at 187, 188, 189, and it goes through to 197 but can't finish. Then it flips over to 3740 and it's given a chance to run for a while. So 3740 continues until we get near the bottom. Then 580 kicks back in and it gets to run from 183 to 193. And then 3832 gets to finish, and then 580 gets to finish, and then finally 3740 gets to finish. Now if I ran this again and again and again, I'll get different results every single time. So that's one of the first lessons whenever you're creating multi-threaded applications. You cannot expect threads to start or finish in a particular sequence. You cannot create code that depends on that. And that's one of the other functions of synchronization, to make sure that things are occurring in a proper sequence. And we'll talk about synchronization later in this series of videos. So this was a pretty frivolous, meaningless little application that we created here. I hope that it makes a little bit of sense of what we did and some of the basics, how we had to create a new instance of thread and pass in the address of the actual method that will eventually be called as a result of that thread's operation. And then we call the thread.start in order to kick it off. The other neat thing was that we were able to get the thread ID, and threads also have a name too that we can get, and we'll talk about that in a future video as well. But they have properties and ways for us to monitor and track them. So the next video is a little cooler. We're going to take this to the next level and show you a real practical use for a multi-threaded application. So hope you enjoyed it. Thank you.